All right, here we go, problem 11. We need to find the area between this curve and the x-axis. So we really need to evaluate, or we need to graph the curve. So we're going to factor out an x value to start, which leaves us with x squared minus 2x minus 3. Then we can keep factoring into x minus 3, x plus 1. So if we graph this guy, we see that we've got x-intercepts at -1, 0, and 3. And since we have a positive leading coefficient, we know our end behavior looks like this. So that means since all of these are single zeros, we must cross through the x-axis each time. So basically we want to integrate from -1 to 0, we want to integrate from 0 to 3, and we want to take the absolute value of each of the integrals. So the integral from 0 to 1, let's see, I'll just set the whole thing up right now. The integral from 0 to 1, and then add the integral from, I'm sorry, I've said it like 3 times the wrong way. Oops, does not want to let me erase. Let's see here. Different color. The integral from -1 to 0 plus the integral from 0 to 3. And I am separating these into 2 integrals because I do need to take the absolute value of each. We know from the graph that this first one's going to be positive, but I'll put the absolute values in there just for fun. When I integrate, I get x to the 4th over 4 minus 2/3 x cubed minus 3/2 x squared, and then I evaluate it from -1 to 0. So let's go ahead. If I plug in 0, I get out all zeros. So that's done. So then subtract out plugging in the -1, so I get 1/4 plus 2/3 minus 3/2. And then coming over here to my second integral, once again, I have x to the 4th over 4 minus 2/3 x cubed minus 3/2 x squared, but now it's from 0 to 3. So when I start to plug that guy in, I'm going to get out 3 to the 4th is 81, then 3 cubed is 27, times -2/3 is -18. And then this guy is going to be -27 over 2. And if I plugged in 0, I'd get out all zeros. But let's just be clear that we need the absolute value of both of these still. Okay, so let me work on simplifying now. I'm going to need a common denominator in this first one, which I'm going to make 12. So I have this negative here, and then I have 3/12 plus 8/12 minus 18/12. Okay, which I'll simplify that first. I have 11 minus 18 is -7, made negative, so 7/12 is this guy. So now over here, if I have the 4 as my common denominator, I'll have 81 over 4 minus, let's see, 74 over 4 minus 54 over 4. So that gives me 81 minus 74 is 7, minus 54 is -47 over 4. But remember, we have the absolute value, so it's positive 47 over 4. Now, when I work all that out, 7/12 plus, and 47 over 4 is, in terms of twelfths, let's see, 3 times 47, I think, is 141. So I get out 148 over 12, which is the same thing as 74 over 6, which is the same thing as 37 over 3. Okay, bear with me because I just realized I made a computation error. So let's get rid of all this. And you guys probably all caught my computation error, but isn't it fun to watch me make mistakes? When I had 18 times 4 over here, I should have had 72 over 4. So 81 minus 72 is 9, minus 54 is 45 over 4, -45 over 4, but with the absolute value, it's positive 45 over 4. So when I rewrite this in terms of twelfths, I get 7/12 plus 135/12, which is 142 over 12, which is 71 over 6, which is, in fact, our answer is D.